Hi, this is Victor and welcome back to my math tutoring channel. In this video, we'll try to solve that integral cos to the power of 9x sine to the power of x dx. As I said in my previous videos, whenever I see a trigonometric function with to the power of an odd number, I have to make one of them at least an even number, and to be more specific, I have to make one of them to the power of 2. And I have cos to the power of 9, sine to the power of 5. It's easier for me to play with the sine to the power of 5. So let's rewrite that integral in a way that I can work with it. So it will become integral from 0 to pi over 2 cos to the power of 9x sine to the power of 2 to the power of 2x sine x dx. It's the same thing. So sine to the power of 2 and all that to the power of 2 is to the power of 5, to the power of 4 multiplied by sine x is sine to the power of 5. But I know there is a formula that said cos square of x plus sine square of x equal to 1. So sine square of x is equal 1 minus cos square of x. I will replace sine square of x by 1 minus cos square of x. So my integral become from 0 to pi over 2 cos to the power of 9 of x 1 minus cos to the power of 2 of x to the power of 2 sine of x dx. And now it becomes clearer for me. I say let u equal cos of x. So my du equal minus sine x dx, but here I have sine x dx, so minus du is equal sine of x dx. So now let's replace cosine by u. So my integral become integral of between 0 now because I have changed the cosine to u, I have to calculate the boundaries here. So I know that cosine of 0 is equal to 1 and cosine of pi over 2 is equal to 0. So my integral become from, instead of 0, I can put 1, and instead of pi over 2, I put 0. And then let's write it. It becomes u to the power of 9, 1 minus u to the power of 2, all that to the power of 2, times minus du. Yeah? But usually, I have to put the lower number in the lower place of my integral and the upper number on the uppercase. So if I want to flip them, I have to change the sign of my integral. So it becomes integral from 0 to 1, u to the power of 9, 1 minus u squared to the power of 2, du. Because like this minus, I can put it like here, and I will change the sign of my integral, and this is how I change it. So now I know that 1 minus u square is like a minus b square, which is equal a square minus 2ab plus b square. This we studied it before. So in that case, my a equal to 1 and my b is equal u square. So 1 minus u square is equal to the power of 2 is equal a square, which is 1, minus 2u square times 1, plus b square, which is u to the power of 4. So let's replace it in my integral. It becomes integral from 0 to 1 to u to the power of 9 multiplied by 1 minus 2u square plus u to the power of 4 du. And that becomes very easy. So I have to multiply u to the power of 9 with my parentheses. It becomes integral from 0 to 1, u to the power of 9 minus 2 u to the power of 11 plus u to the power of 13, all that du. And because I have minus and plus, I can divide that integral into many integral. So it becomes integral of 0 to 1 of u to the power of 9 du minus 2 integral from 0 to 1 u to the power of 11 du plus integral from 0 to 1 u to the power of 13 du. So that's easy. So it becomes u to the power of 10 divided by 10 I will put it between 0 and 1 at the end, minus 2 u to the power of 12 divided by 12 plus u to the power of 14 divided by 14, and all that is between 0 and 1. So here I have to replace u by 1 at the beginning. So 1 to the power of 10 is 1. So it becomes 1 divided by 10 minus 2 divided by 12 plus 1 divided by 14 minus, and I open my parentheses, I replace u by 0, so it becomes 0 minus 0 minus 0, it's minus 0. So it becomes 1 divided by 10 plus 1 divided by 6 plus 1 divided by 14. And you can add those fractions, and that would be your final answer. If you like my video, please subscribe to my channel. That would help me tremendously. And if you push the like button, I would really appreciate it. Thank you for listening.